Plants contain many components. These components must run efficiently in order for the plant to function smoothly. Some of the components contain fluid, and the fluid levels must be watched carefully. Fluid levels affect a component's performance. Often, an indicator is needed to show these fluid levels. There are two types of level indicators, remote and direct. Remote indicators measure fluid levels and send the information to another part of the plant. Direct indicators, which we will talk about here, measure fluid levels by exposing the actual level in the tank. They are more accurate and more reliable than remote indicators. Gauge glasses, or sight glasses, are direct indicators. They are instruments that show the fluid from a tank or vessel and its level. This makes gauge glasses critical to a plant's operation, and their maintenance a very important part of your job. Before we start our discussion, let's be sure of our terms. In this program, when we talk about gauge glasses, we're talking about complete assemblies, like these in front of me. When we talk about glass, we're referring to a part of the complete assembly. Simply stated, gauge glasses are vertical tubes attached to a tank that fill with fluid to the same level as the tanks. As fluid flows into the gauge glass, the vapor in the gauge flows out to the tank. Now, because the tube is transparent, you can see the level in the gauge glass. This indicates the level in the tank. As long as no vapor is trapped inside the top of the tube, the reading will be accurate. Trapped vapor can prevent the fluid in the gauge from rising to the proper level. This will give a false indication of the level in the tank. A gauge glass that is not functioning properly will not indicate problems that can lead to damage in boilers, turbines, and other components, so gauge glasses must be kept in good condition at all times. Now, there are three common types of gauge glasses: tubular glass, flat glass, and multiple port. The tubular glass type consists of two gauge valves connected by a piece of glass tubing. A tubular glass gauge will often have a colored line on the back of the glass to make a clear fluid level easier to see. A second way of making the level easier to see is illuminating the gauge with a strong light. The light can be a permanently installed illuminator, or a flashlight can be used. Another feature usually found on tubular glass gauges is a petcock, or drain valve. A petcock will be located on the lower valve and is used to drain the gauge when maintenance is needed. During normal operation, a petcock or drain valve is used for blowdown. Blowdown is the process that uses gauge pressure to blow silt out of the gauge. The second kind of gauge glass, the flat glass type, is stronger, more rugged, and more suitable for use at higher pressures than the tubular type. So it is often used to indicate levels in steam drums and feed water heaters. A typical flat glass gauge, like this one, has a metal body that is open on both sides. Each side is covered with a thick piece of flat glass held in place by a cover plate. That cover plate is bolted to the gauge. Flat glass gauges have valves used to close the upper and lower connections when maintenance is required. When closed, these valves prevent fluid or vapor from entering the gauge glass. The gauge may have two valves in the top and bottom connections to ensure complete isolation. Another feature on a flat glass gauge is the drain valve. It is attached to the bottom of the gauge and serves the same purpose as the petcock that is attached to the bottom of a tubular glass gauge. Both are used to drain the gauge when the rest of the plant is in normal operation. Some flat glass gauges have illuminators. That's because flat glass gauges are difficult to read if lighting is poor or the fluid is clear. The final common type of gauge is the multiple port gauge glass. Multiple port gauge glasses are often used on high pressure components. The multiple port gauge glass has a slight wedge-shaped metal body with a series of round openings on each side. The openings are covered with thick, round pieces of glass held in place with cover plates. Now, these cover plates are bolted to the body. There are valves in the upper and lower connections so that the gauge can be isolated for maintenance. In some cases, these valves use chain wheels or some other method to allow operation at a distance. A drain valve may be located at the bottom of the gauge so that the gauge can be drained for maintenance. In this multiple port gauge glass, the fluid level is not visible when it is between ports. To permit easy and accurate reading, a special illuminator is used. The illuminator has red and green color screens that color the light reaching the gauge. The light is bent as it passes through the gauge. It bends differently depending on whether there is water or steam in the gauge glass. Now, if there is steam in the gauge, the light will be bent so that only red light comes through. When water is in the gauge, the light is bent so that only green light comes through. Therefore, the ports above the water level shine red, and the ports below the water level shine green. This type of illumination is sometimes used on flat glass gauges as well. It makes their levels easier to read. The valves used to isolate any of the 3 gauge glasses may be special valves. This is a cross-section of a gauge glass isolation valve. This is the body of the valve. The stem is here. The stem turns to open and close the valve. One special feature is that the valves often have a ball check built into them. The ball check cuts off flow if the gauge breaks. When fluid rushes out of a broken gauge, the ball is forced into an opening inside the valve, which stops most of the flow. This keeps the gauge from leaking uncontrollably, even if the glass is broken. However, gauge glasses that have ball checks in their valves are difficult to blow down. The ball check limits blow-down flow. To prevent this, the valve stem has an extension that allows the ball check to be unseated by turning the valve stem toward the closed position. Just before the valve is closed, the extension will push the ball off its seat and open the ball check. This allows the gauge to be blown down through the drain valve. Remember to open the isolation valves when you finish blowdown, or the ball check will not work when needed. We've said that a gauge glass is basically a vertical tube attached to a tank. The tube fills with fluid to the same level as the tanks. We've also talked about the 3 types of gauge glasses: tubular glass, flat glass, and multiple port, and the way they work. Take some time now to read over the material in your text and discuss any problems you have with your instructor. Now that we've covered some basic points about gauge glasses, let's talk about some of their potential problems. We'll identify them, tell why each is a problem, discuss their causes, and describe how each is fixed. There are 6 maintenance problems common to gauge glasses: opaque glass, plugged connections, leaks, glass erosion, cracks in the glass, and complete glass failure. Opaque glass is the term used when the gauge's glass becomes clouded by a film of dirt or silt. It can also be the result of a reaction between boiler water and the glass that turns the glass milky white. Opaque glass is a problem because the film prevents light from passing through the gauge, making it impossible to read the gauge's level. The dirt or silt often comes from inside the tank or vessel where the gauge is attached. Even the cleanest vessel usually has some stuff in it that can cloud a gauge glass. When deposits form on the inside of the glass, there is a maintenance problem. Sometimes opaque glass can be corrected by blowdown. If it isn't corrected, or if there is a chemical attack, the glass must be replaced. Another problem, plugging, is most likely to occur at the isolation valves because the valves restrict the pipe and sediment can collect there. Blowdown usually clears up this plugging. Blowdown is started by closing the lower gauge connection and partially opening the drain valve. This allows the flow to continue until the upper gauge connection is clear. If there is free flow from the drain, the connection is open. Do the same things to the lower connection. Close the upper valve and open the lower valve. Then partially open the drain and blow down until fluid flows easily from it. There may be two drain valves in series on a high pressure gauge. Both of these must be opened in order to blow the gauge down. Remember to be careful when blowing down any gauge glass, especially those under high pressure. Too much flow through the gauge can break the protective mica layer inside the glass. A gauge glass gets dirty on the outside as well as on the inside. Gauge glasses should be kept free of dirt by periodically cleaning the outside of the glass. This can be done by blowing dirt off the glass with low pressure air. When you use low pressure air, wear eye protection. It'll prevent dirt from being blown into your eyes. Also follow any other safety precautions required by your plant. Another common problem is leaks. Leaks are problems for three reasons. They can be a safety hazard, they are a malfunction of the gauge, and they can cause additional damage by eroding the glass and metal parts of the gauge. Leaks can be caused by defective parts, improper assembly, and the heating and cooling that takes place when the gauge is in service. Now, they occur most often when the gaskets fail to hold a seal around the glass. Leaks are usually corrected by replacing the glass and gaskets. If the metal parts of the gauge have been eroded, they have to be remachined or replaced. Glass erosion is the wearing away of the glass parts from fluid flowing over them. This is a particular problem in boilers where boiler water can actually dissolve the glass. Glass erosion can result from a leak in the gauge or from fluid flowing through the gauge during repeated blowdowns. The glass in high-pressure gauges is protected from boiler water by a layer of mica located between the glass and the fluid inside. Mica is a transparent mineral highly resistant to the effects of boiler water. If the mica fails, erosion will take place rapidly. This is a problem because erosion will reduce the clarity of the glass. That makes the glass difficult to read and reduces its strength, making failure more likely. Glass erosion occurs for the same reason as any other kind of erosion. A fluid flowing over a material will gradually wear it away. In a gauge glass, the glass is more susceptible to this kind of damage than the metal parts. Glass damage is corrected by replacing the glass. Cracks in the glass are another problem that can affect gauge glasses. Cracks make the gauge leak. Cracked tubular glass gauges will leak at low pressure. At higher pressure, cracked tubular glass is likely to blow out completely. The glass in flat gauges and multiple port gauges won't crack like ordinary glass. Instead, it generally shatters. The cover plate will usually hold the shattered pieces together and prevent them from blowing out of the gauge. Now, cracks can be caused by defects in the glass, improper handling, improper installation, or the heating and cooling that takes place when the gauge is in service. This problem is corrected by replacing the glass. The final problem, complete failure of the gauge glass, occurs when the glass is blown out of the gauge. Besides being a malfunction of the gauge glass, this can be a safety hazard, especially if the valves don't have ball checks. In a high-pressure boiler, this kind of failure releases high-temperature, high-pressure water into the plant, which is dangerous to plant personnel. Complete failure can also be caused by defects in the glass, improper handling, improper installation, and the constant heating and cooling of the gauge. These are also the causes of cracks, but conditions must be much more severe to produce complete failure. In order to correct this failure, the glass must be replaced. Okay, we've now examined 6 common gauge glass maintenance problems: opaque glass, plugged connections, leaks, glass erosion, cracks in the glass, and complete failure of the glass. We've discussed why each is a problem, how each happens, and how each one is fixed. Take some time now to review the information we've covered. Now that we've discussed gauge glasses and their potential maintenance problems, it's time to explain how they are maintained. We'll be demonstrating maintenance procedures on the 3 common types of gauges: tubular glass, flat glass, and multiple port. Keep in mind that each is a little different. Also, remember that a gauge glass is an instrument that must be treated carefully. Now, before you start work on a gauge glass, be sure you understand how it is put together and its operating conditions. Talk to someone who has worked on the gauge before, or consult the manufacturer's manual. Read the maintenance procedure if there is one. If there are any other available sources of information, use them. You'll need all the information you can get. We'll begin with the procedure for replacing the glass in a tubular glass gauge. The parts we'll be seeing are the retaining nut, the gland, the seals, and the tubular glass. Read the manufacturer's manual and make sure you're familiar with these parts before you start working. Check to make sure there are available replacement parts. You may need new seals. Also be sure that there is replacement glass on hand, because there's always the chance that the old glass will break. When selecting replacement glass, be sure that it is rated for the correct temperature and pressure. All tubular glass is not the same, and it is vital to get the right glass for the conditions. If there is none available, check with your supervisors. The first step in the procedure is to isolate the gauge glass. In some plants, this is done by operators who close the valves and tag them shut. After the gauge is isolated, it is depressurized. You can't take it apart until it's completely depressurized. The gauge is depressurized by opening the drain valve at the bottom and watching the gauge until all the pressure is off. This completes depressurization. If an operator has drained and isolated the gauge, the mechanic who is going to replace the glass should check to see that this work was done correctly. He can then proceed with the job. Now, once the gauge has been depressurized, remove the protective cage. If your gauge has an illuminator, this one doesn't, it must also be removed here. Once the protective cage is removed, you must be especially careful not to bang anything against the exposed glass tube. Loosen the retaining nuts. Notice that 2 wrenches are used to do this. One to turn the nut, the second to steady the gauge valve and prevent its twisting and breaking the glass. When the retaining nuts are loosened, back them off by hand and remove the nuts, glands, and glass. Use gloves to protect your hands in case the glass breaks. Remove the seals from the gauge. They may need to be pried out. Place the parts where they won't be damaged. Now the gauge glass is completely disassembled. At this point, the glass must be cleaned inside and outside. The inside can be swabbed out by pushing a clean, damp cloth through the tube using a rod as a ram. Be careful not to scratch or chip the glass while cleaning it. Now, if you find unusual deposits inside the glass, such as oil or metal chips, point them out to your supervisor. Deposits can be clues to other problems in the plant. Inspect the glass for imperfections. Pay particular attention to the ends of the tube. If these aren't smooth and round, the gauge will not seal properly when it is reassembled. A glass tube that is chipped, cracked, badly scratched, eroded, or stained should not be reinstalled in the gauge. Now it's time to reassemble the gauge. The first step is to put the glass in place. If the old glass can't be reused, install new glass. Remember, there are many different types of tubular glass, and new glass must be suitable to the temperature, pressure, and working fluid that the gauge operates under. Tubular glass comes in standard lengths and may have to be cut to fit a particular gauge. If the glass must be cut to size, accurately measure the space that the tube must fit into. With this type of gauge, the glass will have to be cut so that it's about 1/8 of an inch or 3 millimeters shorter than this distance. This will allow the glass to fit into the available space. The glass is cut with one of several different kinds of glass cutters. This kind is used to scribe a mark around the outside of the glass tube. Place the glass in the cutter, apply pressure to the cutting wheel, and rotate the glass. Do not rotate the tube more than once or the glass may break unevenly. When the glass has been scribed, remove it from the cutter and wrap it in a rag. Strike the glass just past the scribe mark. The glass should break cleanly. Inspect the ends of the tube to make sure they're square. Then polish the ends with a fine emery cloth. The glass can now be installed in the gauge. To install the glass, slip the nuts, glands, and a set of seals over each end of the glass. Place the glass in the gauge valves and tighten the nuts until they are snug. The nuts should be tight enough to prevent leakage, but not tight enough to prevent expansion during temperature increases. Now be careful not to bend or twist the glass when you tighten the nuts, or the glass will break. Next, replace the cage that protects the glass. It's here that you'll replace the illuminator if there is one. Once this is complete, the gauge is ready to be returned to service and the tags can be removed. If the fluid in the tank or vessel is hot, the gauge should be warmed up slowly. Now, this is done by cracking open the upper gauge valve with the gauge drain wide open. When the gauge is warm, the drain is closed. And both isolation valves are opened wide. This puts the gauge in service. Then it should be checked for leaks. Once this is done, the procedure is complete. When a gauge is returned to service, it is put under pressure. If you work on a high-pressure gauge, you must wear full face protection and gloves when returning the gauge to service. They will protect you in case the gauge leaks or the glass blows out. Now let's review the steps in the repair of a tubular gauge glass. First, disassemble the gauge. To do this, isolate the gauge by closing the valves and tagging them. Then drain it. Remove the illuminator if there is one and take off the protective cage. Remove the retaining nuts, glands, glass, and seals. Then clean and inspect the glass. To reassemble the gauge glass, place the nuts, glands, and seals over the glass and put the glass in the gauge. Tighten the nuts, replace the protective cage, reinstall the illuminator if there is one, and finally remove the tags and return the gauge to service. Never tighten the nuts while the gauge is pressurized. Even if it starts to leak, always isolate and drain the gauge. This type breaks easily and could blow out while you're working on it. Okay, take some time now to read over the material in your text. If you have any questions or problems, clear them up with your instructor. Our next demonstration is the overhaul of a flat glass gauge. Like all gauges, each individual flat glass gauge is different depending on its manufacturer. Get familiar with the manufacturer's instructions and the gauge's operating conditions before you do any work on the gauges in your plant. We'll show you what you're likely to run into by using a typical flat glass gauge, but always familiarize yourself with the gauges in your plant. Now, a flat glass gauge has several parts that you'll see during an overhaul. These include the bolts and spring washers, cover plate, cushion, glass, mica, gasket, and the gauge body. It's best to disassemble the gauge while it's hot because otherwise the gauge gaskets tend to stick. The first step in disassembly is to isolate the gauge. The upper and lower gauge valves must be closed and tagged. If there are two isolation valves in each of these lines, both of them should be closed. Remember, working on a gauge that is not properly isolated is very dangerous. Sudden release of pressure from a pressurized gauge can launch parts like bullets, and the gauge's high temperature fluid could burn you. After isolation, depressurize the gauge by opening the drain valve at the bottom. If the gauge does not empty when the drain valve is open, the gauge may still be pressurized. Unless you're positive that the gauge is not pressurized, do not do the overhaul. Check with your supervisor before going any further. If the gauge drains properly, remove the gauge illuminator. Usually, the illuminator is hooked onto the gauge and can be lifted up and pulled off. If the illuminator is dirty, clean it and then set it down where it won't be damaged. It's easier to work on the gauge if the whole thing can be removed and taken to the shop. If it can't, it's usually possible to work on the gauge while it's still in place, but that makes the job harder. Wherever the job is done, the work area should be as clean as possible in order to avoid damage to the gauge glass while it's being worked on. Let's get started. The cover plates and gauge body should be match marked so that they can be put back in their original position. Match marks can also be called witness marks. Once the gauge is marked, remove the cover plates from the gauge. Starting at the ends of the cover plates, remove the bolts and washers. If the bolts won't loosen, try soaking them in penetrating oil. If they're still tight, take a hammer and a brass rod and wrap the flats of the bolt heads. That should loosen them. Remove the two bolts at one end of the gauge, then the two at the other end. Remove the next pair of bolts from the first end, and then the next set at the other. Alternate from one end to the other until all the bolts and washers are removed. Now, note the number of washers under each bolt and how they're placed because you'll be putting them back the same way. Also remember that these bolts are heat treated. If you lose one, don't replace it with a regular bolt. Next, remove the cover plate. The glass can now be lifted out and placed on a clean rag. Make sure that the glass does not get dirty during disassembly. Behind the glass, there'll be a piece of mica. Lift this out and throw it away. The old mica can't be reused. Remove the second cover plate the same way you took off the first. Then, take out the parts the same as you did before. The next step in the overhaul is to clean and inspect the parts. Gauge inspection begins with removal of the sealing gasket located in the gauge body. It must be removed very carefully so you don't damage the seating surfaces under the gasket. A small nick or scratch could keep the gauge from sealing properly. If the gaskets stick and can't be removed easily, Sometimes a special tool supplied by the gauge manufacturer can be used to get them out without damaging the seating surface. When no special tool is available, a brass scraper or brass wire brush can be used. Do not use a steel tool because such a tool is very likely to damage the seating surface. Carefully scrape all gasket material from the gasket seating surfaces. It may help if you put penetrating oil on the gasket to soften it. Scrape along the length of the groove rather than across it to avoid scratching the seating surface. Then remove the cushions from both cover plates. Be very careful, since even a small nick or scratch underneath the cushion gasket may eventually cause that glass to crack. After you've cleaned the gasket seating surfaces and cushion seating surfaces, inspect the gauge body and both cover plates. Check the seating surfaces for cracks, nicks, scoring, dirt, and pieces of the gasket. Also look for cracks and corrosion in the rest of the gauge. It may be necessary to replace the glass with new glass. Some manufacturers recommend replacing the glass whenever it is removed from the gauge. If you decide to reuse the old glass, it must be thoroughly cleaned with a soft, damp cloth. Don't use steel wool, a scraping tool, or an abrasive detergent to clean the glass. Inspect the glass for scratches, clarity, and erosion. Check for erosion by holding the glass up to a light and examining its surface for irregularities. Or you can use a plastic or wooden straight edge to determine if the glass's inside surface is flat. A glass with scratches, lack of clarity, or erosion must be thrown out and replaced by a new one. Old gaskets and cushions must also be replaced. The same rule applies to the mica. New mica must always be used, even if the old mica looks okay. Whenever you handle new glass and mica, wear gloves or use lint-free rags. Once the gauge has been cleaned and inspected and new glass, mica, and gaskets are available, the gauge can be reassembled. First, use a tap to chase the threads on the bolt holes. Blow the holes clean with low-pressure air. Then, use a die nut to chase the threads on the bolt. Coat the cushion groove in the cover plate and the body gasket groove with Molykote or another high-temperature lubricant. This is done so both parts can be removed easily. Place the gasket in the groove in the gauge body. Then, put the mica over the gasket. Handle the mica by its edges, being careful not to bend it. Usually, new mica is marked with a red dot. The red dot should go towards the pressure side, which is the inside of the gauge. Check the glass one last time to be sure it is clean and free of scratches. Even a fingerprint could etch into the glass. Place spacers, pieces of gasket material, at the ends of the glass. Center the glass over the mica so that the glass evenly clears the sides of the recess. The spacers will prevent contact with the gauge body and help center the glass. Lubricate the threads of the bolts with a high-temperature lubricant like Molykote. This is very important because if it's not done, it will be difficult to disassemble the gauge the next time it's overhauled. Place the cushion in its groove in the cover plate and put the cover in place according to its match marks. Then install the bolts and washers. The washers act as springs and must be replaced correctly. If you have any question about how to put back the spring washers, check the manufacturer's instructions or ask your supervisor. Turn the bolts hand tight in reverse order of how they were loosened. Start at the middle of the gauge and work outward so the cover will be drawn down evenly. All manufacturers will have their own methods of tightening bolts, but this is the typical way of doing it. Hand tighten the bolts a second time, again starting in the middle of the gauge and working out. Then, using a torque wrench, tighten the bolts to the manufacturer's recommended torque. Follow the same tightening order as before. Start in the middle of the gauge and work outward, alternating in both directions. Start with about 1/4 of the recommended final torque and go over all the bolts again. Final torque should be reached in about 7 passes. Use the same procedure to install the other cover plate on the gauge. Once both covers are in place, the gauge can be returned to service. If it has been dismounted for maintenance, it must be returned to its regular place. The gauge you will see is not the same one we just worked on, but we will use it to show you how a gauge is returned to service. Clear the tags on the gauge and heat it slowly by opening the top valve and partially opening the gauge drain. Gloves and full face protection must be worn while you do this. Open the drain valve just far enough to permit a small amount of flow through the gauge. Let the gauge warm for about 15 minutes. After the gauge warms up, close the drain. Check for leaks. If any are found, isolate and depressurize the gauge by closing the upper gauge valve and opening the drain. Retighten the bolts with a torque wrench. Start at the center of the gauge and work outward, alternating between top and bottom and applying the manufacturer's recommended full torque to each bolt. Heat the gauge the same way as last time and see if the leakage has stopped. If the gauge still leaks, you'll have to completely disassemble it again. If there are no leaks, the gauge can be placed in service. Close the drain valve and slowly open the upper and lower gauge valves. Then reinstall the illuminator. That completes the overhaul. Okay, let's review the procedure. To disassemble a flat glass gauge, isolate and drain the gauge. Remove the illuminator. Loosen and remove the bolts. Lift off the cover plate. Remove the glass and mica. Remove the body gasket from the gauge body. Remove the cushion gasket from the cover plate. Then clean and inspect the parts. To reassemble the gauge, molycoat the body gasket groove, the cushion gasket groove, and the threads. Replace the body gasket, replace the mica, replace the glass, then the cushion, and then the cover plate. Bolts and washers. Torque the bolts according to the manufacturer's instructions. Place the gauge in service and check for leaks. Then replace the illuminator. That finishes our overhaul of a flat glass gauge. Take a few minutes now to review the procedure in your text and clear up any questions with your instructor. The last demonstration we'll perform is the overhaul of a typical multiple port gauge glass. It's typical because multiple port gauge glasses are made by a lot of manufacturers and their gauges are slightly different. Before you start working, make sure you get to know your particular manufacturer's instructions for the multiple port gauge glass and its operating conditions in your plant. The gauge we'll be working on consists of a gauge body and a number of ports, each of which includes the following parts: a sealing gasket, a protective gasket, mica, packing strip, glass port, cushion gasket, cover plate, and cap screws. These are the parts you'll be seeing as the gauge is disassembled. For our demonstration, we've used two multiple port gauges that are slightly different but contain the same parts. Many plants have spare gauges that are substituted for a gauge that needs to be overhauled. The easiest and most effective way to overhaul the gauge is to do it in the shop, and that's what we'll show you here. However, if it's impossible to remove the gauge, it may be overhauled in place. In order to disassemble the gauge, you must isolate it. Close both the upper and lower isolation valves and tag them out. Since multiple port gauge glasses are used in high pressure components, there will usually be two isolation valves in both the upper and lower gauge connections. Open the drain valve. The drain valve is not always located right at the bottom of the gauge, but can be found by following the drain pipe at the gauge's bottom. Opening the drain valve should drain and depressurize the gauge. If it doesn't drain quickly, it may mean that the drain is blocked and still under pressure. Do not continue disassembling a gauge that you think may be pressurized. Doing that could be extremely dangerous. After the gauge drains properly, remove the illuminator. The illuminator has color screens that make the gauge ports look red or green. If the illuminator or its color screens are dirty, clean them up. After you clean the color screens, put them back in the illuminator. The red screens should be towards the thin side of the gauge body, and the green one towards the thick side. Then set the illuminator down where it won't be damaged. Do all your work in a clean area. After dismounting the gauge and moving it to the shop, the first step is to remove the port assemblies. They can be removed, cleaned, inspected, and replaced one at a time or all at once. If the gauge you've been working on has been in service more than a year without being overhauled, you should seriously consider rebuilding all the ports. We'll show you the procedure on one of the ports, but remember that all of them must be handled the same way. Remove the cap screws from the cover plate. This will allow you to take it off. Then, remove the glass. Be careful not to put it in any place where dirt could scratch the glass's surface. Then remove the packing strip. The cushion gaskets should then come out of the cover plate. Next, take the mica out of the body of the gauge. This mica cannot be reused. Remove the protective gasket found just underneath the mica. And then the sealing gasket, found at the bottom of the gauge port. Finally, clean and inspect all the parts. During the parts cleaning, wipe off any particles of the cushion gasket that might be on the cover plate gasket seating surface. If the cushion gasket sticks, soak the cover plate in hot water. This should help remove the gasket. Clean the gauge body gasket seating surface with a rag. A brass wire brush can be used if necessary. Do not use a steel brush because steel will damage the seating surface. Do not scratch or gouge the seating surfaces on either the gauge body or the cover plate. Look for scratches while you clean the parts. Use all new glass, mica, and gaskets when you reassemble the gauge. You can reuse the original glass if it has been in service less than a year and if it is not scratched, opaque, or eroded. If it is, and new glass must be used, be certain that it is the correct glass for the gauge. If the gauge has a nameplate, check it against the manufacturer's manual. Then, match the glass replacement with the part number listed in the manual. Mica and gaskets can never be reused. Use a bottom tap to chase the threads on the cap screw holes. Use a die nut to chase the threads on the cap screws. Low pressure air should blow out any chips or dirt from the cap screw holes. Be careful not to blow directly against the mica in the other side of the gauge because other parts and the mica could be damaged. Lubricate the threads and bearing surfaces of all the cap screw heads with Molykote or another high temperature lubricant. This will make the cap screws easier to remove the next time the gauge must be disassembled. Put a new cushion gasket back into the cover plate. Wrap the packing strip around the outside of the glass and put it on top of the gasket. An effective way to avoid damaging the glass is to wear clean gloves during reassembly. Place the sealing gasket in the gauge. Do not use Molykote or other types of lubricants on this type of gasket. Next, place the protective gasket and then the mica into the gauge body. The mica may be marked with a red dot. Place the red dot side towards the pressure side of the gauge. Handle the mica by its edges, but avoid bending it. Put the cover plate assembly in the gauge body and screw the cap screws finger tight. Then tighten the cap screws with a torque wrench to the manufacturer's recommended final torque. Do this in several steps to ensure even gasket seating. Different manufacturers have their own ways of tightening nuts. For this demonstration, we'll tighten the cap screw to your upper left, then the lower right one, then upper right, and lower left. Continue this pattern, increasing the torque in steps until final torque is achieved. When you have rebuilt all the ports, the gauge can be reinstalled and returned to service. Once the gauge is back in place, it must be warmed up slowly. First, the tags must be removed from the valves. Open the drain fully and the upper gauge valves a crack. Let the gauge warm for about 15 minutes, then close the upper gauge valves and retighten all the cap screws. Use the same tightening order and torque as before. The manufacturer recommends that the cap screws in this multiple port gauge glass be retightened with a torque wrench whether there are leaks in the gauge or not. After retightening, reheat the gauge for about 5 minutes. Close the drain valve and let the gauge fill up. Once the gauge is full, it can be returned to service by slowly opening the upper and lower valves. Finally, reinstall the illuminator. Make sure that the upper portion of the gauge shows red and the lower green. If it does, the job is finished. Let's review the procedures. In order to disassemble a multiple port glass, isolate it and drain it. Then remove the illuminator. Remove the port assemblies by taking out the cap screws and removing the cover plate. Remove the glass, mica, and gaskets. Then clean and inspect all parts. To reassemble the gauge, put a cushion gasket, packing strip, and glass into the cover plate. Place a sealing gasket, protective gasket, and mica into the gauge body. Put the cover plate assembly in the gauge and replace the cap screws. Torque the cap screws according to the manufacturer's instructions. Heat up the gauge and retighten the cap screws. Then return the gauge to service and check for leaks. Finally, reinstall the illuminator. That ends our demonstration of multiple port gauge glass overhaul and our discussion of gauge glasses in general. We've talked about 3 types of gauge glasses: tubular glass, flat glass, and multiple port. We've seen how maintenance is performed on each one and that there are some general procedures that apply to all of them. Checking your safety manual, consulting the manufacturer's instructions, and keeping your working area clean. These, and using the right glass for the gauge being worked on, are always necessary to ensure effective and successful maintenance. Well, we've covered a lot of material, so take time now to go over all of it in your text and discuss it with your instructor.